Hi everyone, this video is to teach you a little bit more about finding the zeros, which is a quadratic topic, but we're actually going to look at it on a function that's not quadratic. So first, finding the zeros, this word comes from when you take an equation like this one, and you're literally trying to find the values for when y is equal to 0. So that's why we called it finding the zeros. Whatever those x values are that will make y 0, those will be your zeros, your answers. So the way that we've already looked at this is on a graph. On a graph, y equals 0 presents itself as our x-intercepts. So a way to find the zeros on a graph is by looking for the x-intercepts, where the graph passes the x-axis. So here's the x-axis in orange, and I have 3 points where this red graph, this red equation, passes my x-axis. One here at -3, 0, another one here at -2, 0, and the third one at 3, 0. So when I go to write my zeros, I'm only going to write those x values because the definition of a 0 is that y is always going to be equal to 0. I don't need to write that part. So I can say the zeros are -3, -2, and 3. The x values of these points on the x-axis where y equals 0. And this is a really good way, if you're given an equation, to just like count how many you're going to have. You might not get the most approximate answer on your graphing calculator, but it's good to just see what's going on so that when you go to look at the table or solve it another way, you know how many zeros you're looking for. Sometimes we have none. Sometimes we have 1, 2, 3, 4. There's different amounts of zeros. So this is a really good way to see how many you're going to have. Okay, the other way to find the zeros, which is probably my favorite, is on a table. You can see all the values really clearly. You're scanning the table looking for points where y equals 0, where your output's going to be 0. And here they are. I have -3, 0, -2, 0, and 3, 0. And I'm going to write them the same way. I'm not going to write out the full points. The zeros are -3, -2, and 3, the x values of these points. Now, this is a great strategy. The zeros are super clear, except if your zeros happen to be decimals. They won't appear on the table unless you modify the table, or if they ask you to solve for the zeros algebraically. So let's take a look at the last method to solve. This is only going to work if your equation's in factored form. And the method that we're going to use has to do with setting each factor equal to 0. Because think about it. If your y is equal to 0 and you're multiplying these expressions to get 0, the way that we would achieve a product of 0 is if one of these expressions equaled to 0, because anything times 0 is going to give you 0. So if this blue expression equaled to 0, then the whole equation would equal to 0. If x minus 3 equals 0, I can add 3 on both sides. I get x is equal to 0. X is equal to 3. I could set the next expression equal to 0. If x plus 2 equals 0, then x would equal -2. And if 3x plus 9 is equal to 0, then x would equal to -3. So this is actually like where those zeros came from algebraically. My zeros would be -3, -2, that green x should say -2, and +3. So if we're asked to solve for the zeros algebraically, or perhaps we're not seeing them in the table, this would work when our zeros are in factored form. Okay, try this out on your worksheet, and when you're done with the practice problems, make sure you check the exemplar.